Hello, everyone. I am Gresshma Atluri. I'm a cybersecurity risk consultant at Chevron. Over 11 years, I spent across in working with investment banking, oil and gas, energy, and consulting, majorly focusing on CICD pipelines, third-party risk management, and AI security. Across the industries, I have seen one thing in common is it's not just your code gets you into trouble. It's about the dependencies, the CI/CD pipelines, and the third parties wrapped around it. Today, I talk about software supply chain attacks, and attacks just don't hit your application directly, but instead target the tools, dependencies, and the pipelines you rely on. These attacks have grown by 700%, which is a significant amount in recent years, and now one of the biggest risks to the modern organizations. My goal in this session is to share practical real world strategies you can apply to your own DevSecOps pipelines so that they become proactive and resilient. Let's move on to the next slide where we talk about critical threat landscape and supply chain attacks and why supply chain attacks are so dangerous. A modern application is no longer just your code. It's built from open source libraries, third-party software development kits, and cloud services, and CI/CD tooling. Attackers have learned that if they compromise a trusted software, a delivery channel, for example, a build pipeline, a popular open source package, or an update mechanism, that they can impact hundreds or thousands of organizations at once. Most enterprise applications today depend on hundreds of open source components, and many of those are transitive dependencies. And the teams don't even realize that they are using them. That lack of visibility creates perfect hiding places for the attack vectors. We have also shifted from monoliths to microservices and from on-prem to hybrid or multi-cloud and from manual releases to high velocity CI/CD pipelines. That's a great shift of innovation, but that also means like attackers now have dozens of places to slip in. For example, packaged build systems, pipeline plugins, and vendor API. OWASP reflect this shift clearly, and in OWASP top 10 for web, you see the items like vulnerable and outdated components and software and data integrity failures. In the OWASP CI/CD top 10, risks like dependency chain abuse, poisoned pipeline execution, and inadequate identity access management. That's literally a description of the modern supply chain problem. We know from data that organizations who implemented formal third-party risk management programs and strong DevSecOps practices have significantly incidents. So the message is clear. This is no longer just a checkbox or an edge case. Supply chain now has become critical to application security. And let's move on to the slide 3, where we'll learn about modern devastating real-world examples and what their impact are. Let's first talk about SolarWinds, which is a classic example of build system compromise. Nation-state attackers infiltrated the vendor's built environment and injected malicious code into the trusted software update. That single update went out around 18,000 customers, including government organizations and large enterprises. The attack didn't start at the customer, it started at the upstream in the pipeline. And let's talk about Log4j. We saw how one widely used open source logging library could become a global emergency. Most organizations didn't even know where Log4j was running because it was buried deep inside other components. This is the risk of vulnerable and outdated components, which are exactly WASP has mentioned in its top 10. In 2024, the CrowdStrike Falcon content update caused a massive outage when faulty security update crashed millions of Windows systems worldwide. This wasn't a malicious attack, but from resilient perspective, it behaved like a supply chain failure. One update pipeline, global impact. And with platforms like Snowflake, we have seen how attackers can abuse stolen credentials or weaken access controls in third-party cloud data service to access many different organizational data. The common pattern is simple. The adversary rides on something we already trust, an update, an agent, a library, or a vendor platform. Let's move on to the next slide. Here, in response to these incidents, I have worked on defense framework that combines lessons learned and research, industry standards, and real implications across sectors like energy and banking. At high level, the framework has several pillars, and you see shift left in DevSecOps. It brings security in planning, coding, and build stages. That means all the stages of software development lifecycle and secure the CICD pipelines, lock down identities, secrets, and infrastructure for your build and deploy systems. Advanced detection, use behavioral analytics to spot unusual activity, and runtime application self-protection to detect and block attacks from inside the application. Vendor risk management, continuously evaluate, monitor, and third-party tools and the platforms. Zero trust architecture, never test, always verify. For every component, even internal ones. In production environments, when we have applied this framework, we have seen faster detection of vulnerability dependencies and a measurable detection in tampering incidents, and better containment during the potential compromises. I will walk you through each of these pillars in the next upcoming chapters. Let's move on to the next slide. In this chapter 1, I'll focus on how supply chain attacks have evolved and what they looks like today in our software development ecosystem. We have moved from mostly proprietary monolithic application to highly componentized systems that depend on open source, managed services, and cloud native coding. That shift has increased speed in innovation, but it has also multiplied trust relationships. Let's see some modern threat vectors. Let's first talk about dependency confusion. If you think you're pulling the company internal logging from your private registry, but you misprioritize the public registry and an attacker uploads a package with the same name, the build passes, the test even pass, and you have just shipped the attacker control score. And let's talk about typo squatting. Typo squatting, attackers publish packages with the file names with the small changes or just differed by one character. So that means like late night, the tired developer mistypes a name, installs the wrong one, and the malicious payload is in. It's simple, but still works. And let's talk about the CICD compromise. What's a worse than a compromised repo? A clean repo with a compromised build runner. The source looks perfect. The malicious payload gets in, injected only at build or packaging time. The key idea is that modern supply chain attacks are not random. They systematically exploit the way we develop and ship software. Understanding these patterns is the first step to defending against them. Let's move on to the next slide. Let's talk about why traditional security fails in this slide. Traditional security models struggle with these attacks for a few reasons. First, older models are based upon stronger perimeter. We assume inside the network is trusted and outside is untrusted. Distributed pipelines, cloud services, and remote teams, that assumption breaks down completely. Second, many security processes are still focused on static checks at the end of the life cycle, a final penetration test, a yearly audit, or occasional manual reviews. Supply chain attacks, especially those targeting on CICD, often happens in the middle of pipeline, during the builds, packaging, or updates where checks don't see them. When we fully trust code because it is signed or delivered by a well-known vendor, we forgot that signing only proves origin, not safety. If the build system or maintainer is compromised, the signed artifact can still be malicious. This is why we need to change our mindset from inside is safe to continuous verification and defense in depth across the enterprise pipeline. Let's move to the next slide. In this, let's talk about the cascade effect. This is one of the most threatening aspects of supply chain attacks is supply chain attacks these days. Imagine a single popular open source component. That component is used in dozens of libraries, which then get used into hundreds of applications. When a vulnerability or backdoor appears in that one of the component, the impact cascades through entire ecosystem. We saw this with the Log4j. A single component far down in the dependency tree created crisis for many organizations that didn't even know that they were using that. The same cascade effect applies to CICD platforms and security tools. If a widely used build agent or endpoint agent pushes out bad update, like in the CrowdStrike incident, the consequences are global and very huge. This is why we must treat software supply chains as a complex, interconnected systems and not just individual applications. Let's move on to next slide, where this is a chapter 2. We talk about resilience development. In this chapter, let's talk about how to build resilience in your DevSecOps practices so that you can handle this cascade risk. The goal is not to slow the teams, but to bake security into daily workflows. From planning to coding to testing, releasing, and operating. We will look at practical ideas like shifting security left into design and coding. Integrate security checks into integrated development environments and pre-committed hooks. Continuously scanning dependencies and generating software builds of materials. And software builds of materials is a structured list of all components inside your. These are foundations that make later more advanced control effective. Let's move on to next slide. Let's talk specifically about securing the CI/CD pipeline, because this is a pure software factory. As a reminder, as it is continuous integration and continuous delivery or deployment. It's the automated systems that pulls code, runs tests, build artifacts, and ships from them to production. If an attacker controls your CI/CD pipeline, they essentially control what you do. The key controls include majorly identity access management, ensuring that build agents, service accounts, and human users all have least privilege, only the permissions they are absolutely needed based upon their role. And secret management, using the secure walls instead of hard coding credentials in configuration or code. Isolated runners, treating build agents as ephemeral, short-lived mechanisms that are destroyed after each job, reducing the chance of persistent compromise. Network segmentation, make sure CI/CD components cannot freely every internal system, especially production databases. It's also crucial to manage third-party plugins and actions used by CI/CD tools. Each plugin in the effectively code that runs in your pipeline so that there should be a review and approval process for what you allow. These measures align directly with OWASP top 10 CI/CD risks such as inadequate identity access management, dependency chain abuse, and poisoned pipeline executions. Let's move on to next slide where we talk at the chapter 3, where we talk about advanced threat detection. Even with the strong preventive controls, we have to ensure that something someday will slip through. Here we move beyond basic signature-based detection into techniques that understand behavior and context. For example, monitoring CI/CD unusual behaviors like a pipeline suddenly pulling a large number of new dependencies from unfamiliar sources. watching for abnormal network connections from build agents or application containers. This is where security information and event management, CM tools, and user and entity behavior analytics can play an important role. Correlating events and highlighting anomalies that deserve investigations. The idea is to quickly answer the question, is the behavior normal for this system? If not, we want to detect and respond before it turns into full down incident. Let's move on to next slide. In this slide, we talk about runtime application self-protection, a key component of advanced detection in the ecosystem. Runtime application self-protection technology that runs inside your application monitors its behavior in real time. Unlike a traditional web application, firewall that sits in your front end of the application, and this runtime application self-protection can see how inputs are being processed internally and can block malicious actions, even if the payload has already reached the application. For example, if a compromised dependency tries to execute a suspicious command or attempts unexpected file or network accesses, CCP can detect that pattern and stop the request or terminate the session. So that would really help. When combined with these techniques like static application security testing and the dynamic application security testing test, earlier in the life cycle, RASP provides last line of defense in the production line. In practice, we have seen that organizations using RASP, especially for their most critical external-facing services, have much better chances of preventing vulnerability from turning into a breach, even when a supply chain flaw surfaces after deployment. Let's move on to next slide with the chapter 4, vendor risk management, which is very important. This will focuses on how to manage vendor or third-party risk management, which is absolutely central to the key to the supply chain security. Most of the organizations rely heavily on software as service, SaaS, platform as service, PaaS, and infrastructure as service as IaaS providers, as well as we specialized security and analytics tools. Each of these vendors become an extensive for your attack surface. A strong third-party risk management programs looks at security certifications, like usually reviewing the SOC 2 Type 2 reports, ISO 27001 deficiency reports, or PCI DSS, where it is based upon the relevancy of the industry. The vendor owns CICD and supply chain practices. Do they use SPOMS, code signing, and strong IA? Do they have strong IA identity and access management practices? And how their incident response system process looks like. How quickly do they notify customers when something goes wrong? And ongoing continuous monitoring, not just a questionnaire at onboarding. It's like how they are doing the continuous monitoring and how we are monitoring our third parties continuously. Incidents like this, like Snowflake breaches, highlight that it's not enough for a platform to be powerful. It must also be operated securely by both the vendor and the customers. And vendor risk is shared responsibility, and our defenses must reflect that. Let's move on to the next slide, the chapter 5, Zero Trust Architecture. Finally, in this chapter, we talk about Zero Trust Architecture, which is never trust, always verify. Instead of assuming that anything inside our network is safe, Zero Trust assumes that threats can exist both sides, inside and outside as well, organization. In a Zero Trust model for a supply chain and DevSecOps, we require strong authentication and authorization everywhere, often using multi-factor authentications, role-based access controls. Treat every component, repositories, build agents, services as needing to prevent its identity and registry continuously, not just once. use code signing, hardware security modules, and sometimes trusted platform modules to anchor trust in hardware where possible. Apply microsegmentation, so even one third of the environment is compromised, lateral movement is limited. Zero trust is not just a product, it's a design philosophy. If this is applied correctly, it significantly reduces the impact of compromised dependency tool or supplier because nothing and no one is implicitly trusted. Let's move on to the next slide. To make this all actionable, I like to think terms of phased roadmap, foundation, enhancement, and optimization. In this foundation phase and coming next 3 to 6 months, you can enable automated dependency scanning systems and start generating EOMS software bills and of materials for key applications, begin code assigning for critical artifacts, establish basic vendor assessment and TPCRM process, enforce multi-factor authentication and least platforms and critical SaaS tools. Enhancement phase in coming next 6 to 12 months, deploy RESP runtime application self-protection for your most critical external facing applications. Implement behavioral monitoring for CICD pipelines and production workloads. Integrate automated security testing like SAST and DAS scans and container scanning throughout your pipelines. Roll out continuous vendor monitoring instead of one-time reviews. At the optimization phase, it should be considered as ongoing. Tune detection rules to reduce noise and focus on high-risk anomalies. Optimize governance so security controls support, not block development velocity. Implement advanced capabilities like software attestation and provenance tracking. For example, inspired by frameworks like supply chain levels for software artifacts. This idea is to build progressively rather than trying to do everything at once. Let's move on to next slide. Let's wrap up the content. I want to return to key mindset shift, moving from reactive security to proactive defense. Reactive security waits for an incident, breach, an outage, or a critical vulnerability, and then scrambles to respond. Proactive supply chain defense assumes that vulnerabilities and attacks are inevitable and designs resilience into the entire lifecycle. That means treating your DevSecOps pipeline itself as a primary asset to secure. Investing in visibility so you know what components you run and how they behave. Building layers of defense from design and development to build deployment and runtime monitoring. Organizations that embrace this approach are able to maintain development speed while drastically reducing the risk. You don't have to choose between agility and security. You just have to design both intentionally. And I would like to thank you so much for your time and attention. I would like to continue the conversation about DevSecOps and CI/CD pipeline security and our supply chain risk. So feel free to catch me up on LinkedIn. I'm always happy to exchange the ideas and real world experiences. I hope this talk gives you a clear starting point to strengthen your own pipelines and supply chains. Thank you so much.